Alright, so welcome back, and in this video we're going to look at simplifying some expressions here. Before we start, we're going to look at some basic rules. So again, number one, x to the 0 is 1. In fact, anything to the 0 power here is going to be 1. So, for example, if you had 2 to the 0, that's just 1. If you had 100 to the 0 power, that's also just 1 as well. Number 2, if we move on to number 2, it says here that if you have x to the m power times x to the nth power, that's simply just x to the sum of the two powers, so m plus n. So really you're just summing these two exponents up. So, an example is if you had, for example, x squared times x cubed, that would just equal x squared, or x to the 2 plus 3, so we just add that up and we get x to the fifth. So again, if we look at something else, like let's say you had y to the third times y to the fifth power, then again we would just add up the exponents, so we have y to the 3 plus 5 equals y to the eighth. Number 3, moving on, if we're dividing something with the same base here, so x to the m over x to the n, what we can simply do is subtract the powers. So notice with multiplication we're adding the exponents in here. When we divide, we're subtracting the powers. Now this only works if they're the same base. So I'll give you two examples in just a bit. So consider this here. So if you had x to the third power over x, what would this be equal to? Well, again, you have x to the 3 minus, well, what's the power in the denominator? Well, that's just a 1, so it'd be minus 1, and we're left with x squared. But if I give you, or if you see on an exam somewhere, like x to the fifth over y squared, there is no way that I can simplify this because x and y are different bases. They are not the same. So this is not the same as doing x to the fifth minus 2. That would be incorrect. And then our last basic rule here is x to the n is really just x times x times x times x, all n times. So for this might be a little bit confusing, but if you really think about it, it's not that bad. So for example, if I give you x squared, that's really what it means is x times x, so 2 times, and here our power was 2. If I give you x to the third, well, we have x times x times x. That's 3 x's, and notice our power was 3. So what I mean here is that if our power is n, then we have n x's sitting all here, but we're multiplying them. So again, one last one. If I give you x to the fourth, x to the fourth, that would be x times x times x times x. Okay, so using these basic rules, what I'd like to do is look at some more complicated or challenging examples. So if we look at these problems here, so let's look at the first couple here. So we have 3 here. So again, I want to know what is this here? How do you simplify this? Well, you've probably already learned the distributive property, so we're going to go ahead and do that. So I'm going to go ahead and distribute the 2 here, 2x squared, to this first term. Now what I'm looking for is I'm multiplying my numbers together. So what is 2 times 3? Well, that's just 6. And I'm going to get my x's together and my y's together. Well, here I have x squared times x to the first power. So again, keep in mind you're multiplying, so what do you do to those powers? Well, if we go back up to our rules up here, it says that if we are multiplying, we add the powers. So we're going to go ahead and do that right here. So we have, let me scroll down a little bit more. X squared times x to the 1, that becomes x to the 2 plus 1, and 2 plus 1 gives us a 3. And notice that there's no y to multiply out here, so this y squared that's inside will just stay y squared. Then we have to distribute to our other term. So what coefficient is here? Well, imagine there's a 1 there. So 2 times 1 is a positive 2. And again, we're going to multiply the x's, so we have x squared times x squared. Now again, we're multiplying the same, we have the same base here, so it's going to be x to the, and we add the powers, so 2 plus 2, so is x to the fourth. Now there's no y to multiply here, so we're going to go ahead and just bring down this y squared, and it turns out that that's what they want. They want us to distribute and simplify that. Alright, so moving on to number 2, it's the exact same idea here. So what we're going to go ahead and do is distribute once again. So again, we're going to pair up our numbers. So 3 times 2 gives us a 6. Here we have a. Now it doesn't look like there's a power there, but there is a 1 right there. So a is simply just a to the 1. This is also b to the 1. So what is a to the 1 times another a to the 1? Well, we have a to the 1 plus 1. We add those powers up again, and we get a 2. Again, there's no b on the inside to multiply this by, so we're just going to go ahead and bring that b down. Now we go ahead and distribute to our second term here. So we have 3 times 3. That gives us a positive 9. And finally, we have a to the 1 times another a to the 1. Again, we did that already. That gives us a squared. And b to the 1 times b to the 1. Well, again, that's a b, and we're going to add those powers once again. So 1 plus 1 gives us a 2. Alright, so again, not much going on there. Pretty straightforward. Let's look at number 3. In number 3, we have 2x to the 4th plus 6x squared plus 18x all divided by 2x. Now, this, we can go ahead and rewrite it as 2x to the 4th divided by 2x plus 6x squared divided by 2x plus 18x divided by 2x. And what we can go ahead and do is now divide each term individually. So what is 2 divided by 2? Well, 2 divided by 2 is simply just 1. Now here we have x to the 4th divided by x. Now notice that our bases are the same. So what do we do when we divide? Well, we subtract the powers, right? So the power here is a 1. So 4 minus 1 is 3. So this turns into x cubed plus, here 6 divided by 2 turns into a 3. And then x squared over x, well, subtract the powers here again. So 2 take away 1 is just 1. Plus 18 divided by 2 is a 9. Now here you got to be careful. You have a 1 on top and a 1 on the bottom. So you're going to have x to the 0. But wait a minute. What is x to the 0? What is anything to the 0? It's just 1, right? So it turns out that this here is our answer. Now you don't have to write the 1 here if you don't want to. We can simply just write x cubed plus 3. We don't even need to write the power of 1. We could just say 3x plus 9 there. Alright, we're going to go ahead and finish up with these last two problems here. So 2x over y to the 4th, what does that equal? Well, first we got to figure out, well, what in the world does this mean? Well, remember when I said this up here? So this rule right here, number 4. X to the n is really just a bunch of x's n times, so x squared is x times x cubed is 3x's. Well, this is simply just going to be 4 of these because we have to the power of 4. So we have 2x over y times 2x over y times 2x again over y, and another one because we have 4 here. And now all we have to do is multiply fractions. Now we just multiply straight across. So let's look at all our numbers here. So what is, let me change my color, what is 2 times 2 times 2 times 2? Well, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. And what is x times x times x times x? Well, remember when you're multiplying, you're adding up all your powers. So 1 plus 1 plus 1 plus 1 gives us x to the 4th. And again, if you do the same thing with the y's, you should also get y to the 4th. Now, if we look at our last problem, how many of these do we have? Well, we simply have 3 of them, right? Our power here says that we have 3x over 2y's. So that means x over 2y times x over 2y times x over 2y. And again, if we apply the same techniques that we've been using all along, the powers here are all 1, and when we're multiplying, we just add those powers. So we end up with x cubed over, what is 2 times 2 times 2? That's 8. Y times y times y. Again, you're adding up all those powers, so we get x cubed over 8y cubed. Now here you got to be careful because the temptation is that, oh, well, I'm dividing, I can subtract those powers. But keep in mind that the bases here are not the same. For example, you have x here and you have a y. Those are not the same, so we cannot combine these two terms here.